last lesson we learned about introduction to logarithms. We learned about the idea of them, right? We learned about how the logarithm is the inverse of the exponential functions. This lesson we're going to learn about the addition law of logarithms. So the addition law. So what does it state? So we're going to prove this, okay? So what does this state? It basically says for log base A and B plus log base A and C, so they have the same base. This gives us log base A B times C. So we're going to prove this mathematically. So how do we do so? I'm just going to let log A base A B be x. So that's x. I'm going to let this be y. So what happens here? So I know that x is equal, so x is the time for for 1 to double, to increase its size by a factor of a every minute, so that it gets to b after x minutes. So you start from 1, you increase by a every minute for x minutes, and you get to b, right? That's just the logic of log. So for this is actually the inverse of an exponential function. So this actually gives you a to the power of x is equal to b. So you're asking how much minutes do I double 1? How much minutes do I increase the size of 1 by the factor of a every minute such that it ends up with b? So this expression tells you that if I increase 1 by the size of factor a every minute for x minutes straight, I get b as my final size. So that's just our exponential function. So that's our new equation. Same for this. You start from 1, and then you multiply by a every minute until you get the size of c. Now how much minutes does it take? It takes y minutes, as we define here with our variable. It takes y minutes, or it takes log a c minutes. So this means that if I took a and I start with 1, and I increase the size of 1 by factor a every minute for y minutes straight, then I get my final size c. So I have two expressions here. So if I decide to multiply ax and a to the power of x and a to the power of y, then what I get is gonna be b times c, right? So what I get is b times c. That's just plugging in the equation for two sides. So I have ax plus y. So I have ax plus y equals bc. Okay, so this is a new different thing because this is another function. So I first operate my size 1 for x minutes straight, every minute increasing it by a factor of a. Then I operate the resulting factor ax, a to the power of x, by y minutes straight. So I increase the size of a to the power of x by a factor of a every minute for y minutes. So then I get b times c as my final size. How do we write this for x plus y on one side of the equation? So we want x plus y equals something. So x plus y is going to be equal to the amount of minutes, right? The amount of total minutes it gets from a to bc. So that's just log. So if we plug x and y in though, x is actually log. So when we defined x, it's actually log base a b plus log. So when we defined y, it's log base a c. Then it's equal to log base a b times c. So that's just the law we're trying to prove. This is the same thing as the one above, right? So we've already proved that addition law. Now one interesting thing you can find is that this is similar. This is the exact opposite of the multiplication of exponentials. So because for exponentials, we have 2 to the power of a, or you can say if you have x to the power of a and x to the power of b, you get x to the power of a plus b. Meaning that if you multiply If you multiply x to the power of a by x to the power of b, then the exponents add. Here, if you add log base a b plus log base a c, you multiply b and c. So one is multiplication leads to addition. Second one is addition leads to multiplication. So these are also inverse. So thanks for watching. Bye.